Okay, so I'm going to talk a bit about version control and specifically Git. Git is created by Linus Torvalds, the guy who also created the Linux kernel. He's a bit special. He cares about his software, and that's also why this is taken off. But this is a quote from the Git mailing list where someone's been very nice and implemented very nice color encoding of the output from Git commands. And he thought it looked like digging out your eyes with a fork. So they had to change it. So he's a good example of one of the benevolent dictators for life, like Python founder. He controls Linux and Git very well. So one thing that's very important is that you should definitely use version control when you write software, especially if it gets larger. Linus thinks so. It's going to be, you have to spend some time to actually learn to use it. But once you do that, you'll find that it's pretty much required. Just a quick outline. I'm going to go through just a quick introduction of version control software in itself. Then some more details about Git. And at last, I'm just going to mention some quick things about how to do packaging in Python. But in general, this is not about Python. This is about any kind of source code. Actually, any kind of files that you might want to have a history on. So, for example, for thesis work or papers, this is also a very good thing to do. So, version control. First of all, you want to have some kind of history of the development that you've been doing. Not only because it's nice to see what's the evolution of the code, but you also want to be able to go back and forth. Maybe you introduced an error, you want to not deploy that to some system that will break for everybody. The second good reason is to be able to do collaboration. So a lot of you obviously do a lot of collaboration with other people, and if you don't want to package all your software, send it to someone else, and you manually have to afterwards merge things together that you both worked on, version control offers a solution to that. It also, and I'll get a lot more into that, it makes it possible to do experimentation on your code or on your text or whatever you have without actually breaking stuff. You don't have to worry about that something breaks or you can never get back to the state that you had. If you've created a commit, and we'll get back to what that is, you can basically always recover your state. So as I said before, it might take a little time to learn, but it's worth it. So just a quick terminology slide. What you usually have in any version control is the notion of repositories. In most version controls, it's basically just a directory. You check out the repository into a working directory. We'll get back to that a lot later. You do commits in order to change your code or whatever you have. You then update remote repositories or the shared repository with your changes. And then there's the notion of a centralized version control system versus a decentralized or distributed. So let's look at the centralized. So in this paradigm, everyone basically commits to a central server. There's a lot of problem with that. As you can probably imagine, you have a single point of failure, that server goes down, nobody can access or commit any code. If you're not online, if you don't have that server available, you cannot commit. And there's a couple of historical implementations of this. One is CVS, and that's basically what people used in the early days of computing. The other well-known of these is Subversion, and actually also used a lot today, but is slowly getting replaced by distributed source control. So actually, Linus Torvalds has a good quote on CVS. He basically said, we're going to develop something, and CVS is the baseline for how we shouldn't do things. And if we're in doubt about anything, we should basically do the opposite of what CVS does. So that's nice. So decentralized. Basically everyone has a copy that is equal of the repository. It can be in different states, but it's just as good as the other ones. You can commit to your local repository and work on that offline. But when you're online, you can then push to some remote repository that's shared between people, or you can pull from it to get the other people's updates. Usually it introduces something called branches, which is a very nice way to experiment with new code, just doing something crazy that you don't have to release to everybody else, but you can still work on the what's called the master branch, which is what everybody else has. So there are different implementations of this. Can you just go away? Okay, anyway. So there are different implementations of this. You can look those up. Obviously Git is the one we're going to focus on here. So I'm just going to introduce some basics of Git. It's a very complicated system. I don't fully understand everything of it, and if you don't, it's okay. It's Linus made it, so it's okay if you don't understand it. But basically, if you Google for any of these, you get very good references to help. So the Git tutorial is a nice just introduction to how to do basic stuff. The Git book has everything if you want to dig deeper. So let's get started. What you basically do is go to your directory and you call git init. You're now setting up Git so that it starts to work with your files. So by now it's an empty repository. The directory is empty, but we haven't added anything to it. So you can call git status command, which is something you use a lot. You get an overview of what's going on in your repository. So you can see we're on the master branch, which is a special name branch. We are currently working on an initial commit. It's a special state where it's just been initialized, but we haven't added anything to commit yet. So it tells us what to do. We should add something.
So by the way, for those that don't yet have Git, if you go back to the installation page of the website for the class, you should see some pointers to various flavors of Git. And it should just be a drop-in installation. There's a Windows link, there's a Mac and Linux link.
Yeah, it should work on Windows as well. Yeah, if you have any questions anytime, just stop me. Yeah, so let's try to just look what's what's in the directory now. So we see that Git has created in the empty directory a new directory called .git. This is where it keeps track of all the objects, everything that has to do with Git. It also means that it's basically just in the directory. If you copy this directory to any place in the world, it still has the same Git directory, it still has the same history, it has everything. So let's create a file, readme. We're just gonna put some stuff in it, and over here you can see how the status updates. We now have an untracked file called readme. So it shows you that there's something in this directory that I'm not in control of. You should know that. Okay? So we're gonna add it just as it said, right? It said use git add to track whatever untracked files you have. So we're gonna add it. In the updated status, you can now see that this is a change that is to be committed. So what we call this is a staging area. You basically add stuff that you stage for a commit. And then at some point you can go ahead, you can do whatever you want. You can add more files, you can change it. At some point we'll go ahead and commit it. So if you add new files or if you change this, you have to know that it's then again been unstaged, so you have to stage it again. So no changes will go into the repository without your consent. We make a commit. The status is now, there's nothing to commit, there's nothing staged. It doesn't show you all the other things from the empty state because it knows that you know how to do stuff now. And we have a clean directory. Okay, that's basically how we get started. And this is the output from, it just shows you some stuff about how it does things. One file has changed, the readme file. One line has been inserted, the one line that was in the readme file. And it gives it a number. So this number is a unique number that corresponds to this commit. Okay, so there's lots of things that you can do. And I'll go through a lot of them later. But one thing that you should know is git help. I use it extensively all the time to, what was the argument to this command? And you basically say git help, or you say git help command. So git help status will give you whatever you can do with status. So just a quick slide of what's actually going on. Yeah. Where do you run it from? I would assume that the Windows installer would install a git command. So you open a terminal. You have to have a terminal.
cmd.exe. They download something called git bash. Yeah. Oh, it's got its own terminal. Okay. It has its own terminal.
Oh, okay. I don't know. I've never.
That works, and it's a subset. It's a little bitty bash thing, and you can cd around the mat, and then you can do all these commands using that.
Also LS and stuff.
Yeah.
Oh, that's
I'm
nice.
getting some errors though, like your email address.
My email address?
Well, that's, I mean, it's like, you just get into this.
Maybe go on the IRC channel and then we'll get some of the templates on there. People having trouble with solutions.
Yeah. Or we'll figure it out afterwards in the breakout session. So just a quick slide on the internals. So what Git basically does, it keeps track of commits. That's it. Every commit has an author, a timestamp, a message. As you've seen, we created a commit with a message, and you'll see later how that shows up. But then it has parent commits. So what Git basically does, formally, it's a directed acyclic graph. So it creates a graph where every commit points to a previous commit. So we'll see a lot more about how that works. And you can see this is the actual name of a commit internally. And you can use any first number of digits that makes it unique to identify it anyway. So just quickly again, an overview of the status command. So this is an example where we've modified different things. We've actually staged a file for commit. We have modified a file that needs to be staged in order to commit it, and we have an untracked file. So again, this is untracked files, staged area, and the actual untracked files, modified files, and staged area. So let me go through a workflow for how you'd use this locally. So we haven't talked about the collaboration part yet. First, we'll see how to use this as a history locally. I'm going to add a new line to the README file and say get status. I get whatever you saw before, modified README. Then there's a command that you should also use a lot. It's called git diff. It'll show you what has changed in all of the files that have changed. So, so there's a lot of stuff in there. What you should take away is the pluses and minuses will be the lines that you've added or deleted. So it works on lines always. If you change a little word in line, that whole line will be changed. We then commit it. You can see I've used a small trick here, which is the A, which means that I don't have to add my changes. I would have had to say add README because it's modified and not staged. But with this .a for the -a for commit, I just say add everything that's not staged but modified, and commit it with this message. So this will not add your untracked files because you probably wouldn't want that, but it will add everything that's already tracked but changed. You can do a get status. This is just to get a feel for what I would do if I made changes. I'll say, okay, status is fine now, it's committed. And then there's the new command git log, which is a very nice command that gives you an overview of what's happened. So this is output from git log. You see that, as I said, there's an author, there's a date, and there's the ID. And then there's the message. And this is basically everything there is. This is all your commits that Git knows about in this stage. So there's a lot of command line options that you can give to git log to get other views, but it's very useful. So one important thing is what happens if you want to undo something. That's one of the reasons why we're using this, right? So there are several different ways you can do this. You've just committed something, and this is kind of in the order of how often I use it. So it's very often that you commit something, you just want to amend it, you just want to change the message, or you forgot to put a file in there, or whatever. You use commit amend. It'll assume that you're just you can put the message in here as well, and it'll update the message. But basically, you stage whatever you want to have amended to the previous commit, and you commit it. Now you can also go ahead and, if you've changed the file and you figured out, okay, I just messed it up even more, I want to start over on this file, you go ahead and check it out again. So what I told you was that in the branch that you have, in the repository that you have locally, you can check out from to a working directory where you're actually working on files. So that's the difference between the working directory and the staging area where it's ready to be committed, and the actual repository where it's been committed. I'll show you some more of that later. But this means basically disregard any changes to the file and check out whatever is in the repository. You can also go ahead if you've staged something for commit. Yeah? Oh, okay. Okay, so it might be an old PDF up there, but that doesn't actually matter. So these are optional. It's just for clarity in the command. So I usually never use them, but that's how it says you should do things. So yeah, so you can also, if you've staged something for commit and you figure out, okay, I wasn't ready yet, you can reset your working directory to be that of head, and head here is kind of a reference to the current repository, to the current state of the repository that you're working on. Anyway, this you'll know when this is useful, and you'll know how to look it up. Git revert is something where you've done stuff, some commits, you want to remove them. Basically creates a new commit that removes all the other commits. So one thing that you should take from this is that it's very hard to get rid of commits. You basically can never lose a commit. Once it's committed, it's safe. There is an exception to this, and I'll show you later. But that's the rule of thumb. Oh, here it disappeared. Okay. So another thing that you can do is a hard reset, which you probably won't use anyway. I'll go on. You can read about it in the help command. So branches. Branches are very important, as I said earlier, to encourage experimentation on your code, or if you want to do something, you just want to make sure that you're not sure if it's going to work, you're not sure what's going to happen, you just create a branch. So first we can call the branch command and list all of them. And what you see is we only have a master branch, and that's the one we're working on. So it's very helpful to think about this as the graph that it is, because you're going to branch off the graph, and you're going to start a new branch, right? So let's say we branch off. We're going to check it out. This means that head, which I introduced before, which is the reference to whatever we're working on, does not anymore point to master, which it did before. It now points to, oops, sorry, this naming is, yeah, you get it. This is the new branch testing. So by checking out, we're now pointing to the other one, but they're still pointing to the same commit, because just by branching, we haven't actually gone into the branch and made new commits. We've just created a new branch that points to some commit. Remember, all commits are basically just pointing backwards in the tree to something. So let's see what happens if we actually make a change in the new branch. What happens is that the new commit that we just created will point back to the old commit. Master is still at the old commit because we're working in a new branch. And the head is pointing to the testing branch, which is pointing to the latest commit of that branch. So let's see what happens if we go back to master and we go back and forth between branches by checking out. So you can think about it as moving the head pointer. And now we say merge the new branch into master. It'll then fast forward. It's called because it's basically forwarding master to point at the most recent commit of the testing branch. So this whole block will move over, basically. It's not actually that simple with merge. What I'm telling you is actually something called rebase, but I'll tell you about what the difference is between the two. But that's how conceptually it works.
How does this allow you to collaborate with people?
Yeah, so this is the next slide, and the next many slides. Yeah. Question? Oh, okay. So, collaboration. What you usually do, or what you might already have seen, is someone saying, clone this repository. Let's say, okay, what? What they mean is you call git clone and whatever path they give you. So git is very nice in the sense that it's tied directly to the directory, so you can put it anywhere. You can put it on a SSH host. You can put it on the local machine somewhere. There's some notion of a git server that can also live on. So all of this you can see, and it can actually be served over HTTP, so regular web protocol. So this is different ways to clone a repository. So if someone asks you to clone something, this is what you do with that URL that they gave you. So now you're going to change stuff in the repository that you've cloned. You're going to add something to the README. You're going to make a git diff to make sure that you haven't blown things up. And you're going to commit it. Again, I'm using the A here because otherwise I'd actually have to add README. This is a shortcut. And you say you've included your stuff. So what you now will do is, if this is a repository that you have write access to, you can actually push your changes. It might also be that you only have read access, and you would basically just work off of this. Or you could branch off a new branch and create your own remote with the copy, which is called forking, and we'll get into that. But basically, what you would do if you had write access is you'd pull any changes that has happened up at the remote branch and then push your own. So by pulling, you get all the changes that has happened. Is that mine? Yes. I think so. Yeah. So by pushing to the remote branch, you're then putting in your commits. So everyone else can pull and get that. So the idea is you have your own working tree, you commit to your local branch, or you check out from it. And from that local branch, you can push and pull from a remote branch. So how to actually, this is something that you might want to do pretty early on because you have some new stuff you want to do and you have access to some server somewhere, some SSH server that you can push and pull from. You go there, you create a new directory which is empty, where you want the code to be shared. You then init, and notice that we called get init before in a working directory, which didn't include the bear. And the bear is just a way to say that we're not going to work in here, it's just going to be used for sharing. You could also just have a working Git repository that is shared. It wouldn't make any difference other than space requirements. And some other things that doesn't matter. So the shared thing, you find out is important if you want multiple users to push to this repository. Because otherwise there'll be permission problems. So this is basically how you do that. You then go to your local code, where so remember this is empty. You then add what's called a remote to your repository, which looks like this. Now we have this my server, we have this path. So we add this. Oh, that's been capped. Okay, it's supposed to be a /myrepo.get here. So you can then push to origin, which is the remote you've called origin, and you push to the master branch of that. And now your code is basically shared. Then you can give anybody else, you can give this URL and say that they should pull from it. Of course, they have to have a user in order to do that. But so what happens if now you've changed something, someone else has changed something, and you need to merge the results? So Git will do whatever it can in order to do this intelligently. in an intelligent way. But there might be some cases where it's not possible. So then you would get a conflict, and you say, oh no, this is going to be a headache. So what you basically get out of a conflict is that it's changed the file that is conflicting to include these areas. So basically it says, in head, you've changed, you have this. But in the other guy's commit, they have this. So what am I supposed to have in there? So you know, as the merger, that you're just gonna have both lines. So you're gonna change the files to include both lines, and not all of this other stuff. You don't have to add this file manually, and you cannot use the A thing for this because Git really wants to be sure that you've merged this correctly. And you then make a commit of that conflict resolution. So this is a little aside. There's a good command, or good or bad, depending on how you see it, for figuring out who's actually changed something. It's called git blame. You can use it to blame people. Maybe you shouldn't always do that, but you could. You need, so another place where I work, we had this very good thing where basically if anyone found something stupid in the code, we would literally print it out on a paper and put it up on the wall. The git blame output, so anyone could see the stupid stuff that guy has done. So you have to be sure that you're not pushing stupid stuff. No, of course not. You just have to, and this is another good reason to branch out your work, because pushing to a branch that is yours, nobody expects anything to be working. But when you push to master, or whatever the branch is that is the stable branch, you're not gonna, you shouldn't introduce stupid stuff, and you wouldn't go up on the wall. So another thing that I want to tell you a bit about is this Git thing has several ways of doing things, but one way is what is called the GitHub flow, which is something, I'll tell you a lot more about GitHub, but the flow in itself is basically just you clone whatever repository you get. So imagine you want to change something, you want to add a new feature. You then basically make a new branch, and you pull the remote branch into it. So this is a shortcut for doing that. You say, I want to check out the code that is in my local repository, but I'm going to make a new branch out of it. So it's basically just the git branch command and the git checkout command in one. So you then change stuff, you commit it. What you then need to do, and you don't have to worry too much about that right now, is to rebase master or merge with master in order to make sure that you do all the integration with the stuff that's actually been changed on the server. And then you're allowed to push it to a new remote branch. You then tell this to someone who's going to check the code. So imagine that this code is important in some way, right? It's running some calculation that needs to be run stable. So someone needs to read your code and make sure you haven't introduced stupid stuff. Once they've done this, they can then go ahead, merge. They can make iterations of this. They can make new commits to make it work perfectly, and then they can go ahead and merge the new feature. And you make sure that whatever's in the master branch, or whatever it's called, is stable, or at least has been checked by someone. So this is a way that's emerging for a lot of software companies to do things. You go through this flow because it's much easier to keep track of what's been being worked on and what's going on.
So when you say git rebase master, you are actually merging it with the master?
You're taking everything from master. So basically, if you think about it in the graph sense, you're pushing that master branch up. So
and that's locally, right?
Fast forwarding. Yeah. So this is all locally until you do a push. So pull and push are the only remote commands.
So then you say git push to your origin. That's your new repository, right? So you're not pushing your master.
Exactly. So what you're doing here is on the my new feature branch, you're taking everything that's new from master and put it in. So someone might have pushed a lot of new stuff into master while you took 2 months implementing this feature. So you need to make sure that your stuff also works with everything else that's been going on since then, since you branched, right? So that's what rebase does, and you then push it. Yes. Okay. So let me talk a bit more about merge versus rebase. So before I talked about what's actually going on when you merge, and the answer is that it will create a new commit with the merging of the two. So you can basically use merge and rebase. So rebase, what it does is it merges the actual commits down in the timeline. So now these won't exist anymore, they'll just be a linear time. You can use them they're basically the same, but what you get out of it is a better history. So if you go back to a very complicated project and everybody merged everything, there'll be thousands of branches sitting everywhere that's been merged down to new commits. And if you do rebase, as I showed you, it'll be much cleaner. But don't worry about it too much. If you can use both. The only thing to have in mind is you should not rebase if you already pushed the commits. So another thing I should mention, maybe one of the optional exercises in the breakout is the interactive rebase, which is a very powerful way to go down in your history and delete commits. So this is one way you can actually lose commits, or merge them or rename them or whatever you want. So one thing I want to introduce as well is tagging. So tag is basically just, I want to call this state of my software something. So usually you're using it for releases of software, right? You want to make sure you know when was it that I actually had release 1.0. Use a tag for that. So you can say git tag, you'll see, okay, we have a 1.0, and then you show 1.0, it shows you who actually tagged, all that stuff. You'll get to use this as well. So you can then create a new tag, which is called 2.0 with the message, and you can show that. I thought I should. And then you have to push the tag, just as you have to push the branches, you have to push the tags. So now let me talk a bit about GitHub. So GitHub is basically making all of this this whole process of managing remote repositories and users and all this stuff is making much easier with a pretty web interface. So some highlights. Your code is now saved in the GitHub cloud. This is a good thing if you want to make sure it's not disappearing. I don't know if you don't like to have things in the cloud, but it handles whatever you need to do to collaborate on code. It adds a social component to that, and some project management, such as you can create issues with your code, such as fix this or fix that, and wikis, such as if you want to have instructions on how to do stuff in your code. You can use it for free if you're hosting open source. Otherwise, you have to buy a plan for, I don't know, $5 or something, and you can have private repositories. So I claim that it's revolutionizing software development in the way that it's made it very easy to collaborate on code, and lots of things have happened since it started because people have kind of opened their eyes for how to do stuff. And there are also other alternatives that you can look at. So Bitbucket is, both of these are clones of GitHub, but this is, you get unlimited free repositories with Bitbucket, which might be nicer. They're not as nice as GitHub, but it's free. And there's also a local one that you can install on your own server if you want. So if we want to look at the interface of GitHub, you can see that this is how you would represent the GitHub flow that I showed you earlier. You're gonna have some branch that you want to merge into master. So basically, you say this is called a pull request because you request some administrator to pull your changes from your separate branch, and this guy can now go in and look at all the code and give comments if something is not right. You introduce new commits to fix stuff, and at the end, you'll just say, I'm happy with it, merge pull request. Some administrator will do that, and your stuff will have gone into the master branch. So this is how a lot of open source code is now working. They create a repository at GitHub. They say, pull requests are welcome, so people go ahead and they fork the code, they make their own branch, they make their changes, and they say, if you want these changes, you can get them by making a pull request. And there might be some discussion that it's not good enough, but it ensures that whoever's in charge of the actual software gets to have the last say. So I'll just quickly talk a bit about Python as well. Oh, sorry. Yeah, let's have some questions now.
So before you do,
yeah.
Is there a way to flag files if you do not want to version?
Yes, that's a good question.
Files?
Yeah. So what you would do is you'd create a special file called .gitignore, and in that you can put whatever files that you want ignored. So it won't show up in the status command as untracked files. So that's actually how you always do if there's something, and especially if you compile code but you don't want to send around the actual compile code, you ignore all files that have been compiled, stuff like that. You can have complicated expressions for how to match. Sorry. Yeah.
Just to be clear, by default, Git doesn't track files. You add them, and then it starts tracking them.
Sure, but they will show up in the untracked section, and that will be ugly.
Right.
Yeah.
So I wasn't sure if the first question was asking.
No, that's a good point.
When you start a repo at GitHub, the first thing they ask you is, do you want us to add a .gitignore for you, and what type of code do you think you're going to be writing? So there's actually a .gitignore that's sort of the standard one for Python.
Yeah, for Python you want to ignore PYC files because they're compiled. It doesn't make sense to ship them around. If you have an editor that creates, files for backup, you can just Yeah, exactly. Ignore it. So
So do you have any problems at all with like the database getting corrupted and things like that? And so you
the Git database?
Yeah.
I have never experienced it. I mean, there is ways that it's a powerful tool, and there's ways that you can mess it up. But if you follow kind of the right way to do stuff, you won't. So you would rather go to the manual and just see how people do this if you have some complicated thing that's going on.
In that regard, so what I understand, I still have
Okay, yeah.
So is that true? Is that
So yeah, I guess that's true. You typically want to keep your working directory clean, so you want to either commit it or something like that. So when you want to check out a new branch, you need to make sure that your working directory is clean. So what you do is you commit it or you throw it away. There is also something called git stash, which will just hide it for later. But I tend not to recommend that because you'll just stash a lot of stuff and you'll never use it.
And more, do you want to say something about the sort of security of the hashing, what that actually means, going backwards in time?
So what do you mean?
Well, the story
Every-
about the Linux kernel getting hacked and stuff.
Oh, maybe you should talk.
Well, yeah, this is me in Kansas again, but I heard at some point with, maybe, I think it was with Subversion, the actual Linux kernel effectively got hacked by somebody going way, way, way back into like the early 90s and changing a couple things. And then the way that it got propagated forward and people started checking stuff out, there was no way to know that the kernel had gotten hacked or the files had gotten hacked because the files themselves were not effectively hashed. And so this really long number string thing that Henrik was showing you is basically like perfect hashing of the entire history up to that moment. And so if somebody goes through and tries to change something in the history, there'll be a conflict which pops up. And so part of why people really like Git for very, very large code bases is that there's no way to essentially break it.
Yes, that's a good point. Yeah, so the ID, the very complicated string you saw, is a hashed representation of all the history of the repository. Huh? Yeah.
Until they break SHA-1.
Yeah.
It'll take a couple of years. Or quantum computers or whatever. Any more questions? Okay, I'll just say a couple of things about Python. So imagine that you have some Python project. You want to release it as a library. What you actually need to do is create a directory structure that follows a convention of Python libraries. So you go ahead and you create this directory structure. You have your README file, you have your different files here, and then you have your code in here. So what you see here, and we've talked about modules inside directories, right? Anyway, so
I mentioned that yesterday, but
Yeah.
I didn't actually do it.
okay, so this is basically how you create a module that is nested inside another module. So what you would have here is a module called towel stuff. It would have a sub-module called location and utils. So what you would have to do from your code is import towel stuff dot location in order to get to this. So this is how you build up your nested modules. In this init file, you can then put whatever needs to be loaded when the module loads. So you should, if you want to do this, if you have some software that you want to release, you should refer to the packaging guide. But just to get you a sense that there's actually a conventional way of doing this. Also, you should, and this is something that is going to be touched upon tomorrow, have a test directory where you write tests for your code. So if you look at how this would look from the, if you write a command, you would basically, you can now install this by using the usual Python installing method. And from whatever program you have, you import these different modules. And you can call it. So this is just a quick reminder of.
I haven't seen the setup.py yet.
Okay.
So we haven't done this tutorial. We'll talk about that tomorrow.
Yeah. So it's basically just to say you can set up stuff the right way, and now you want to release this code. You go to GitHub or some of the others. You basically add a new remote that is called Origin that lives on GitHub. And you go ahead and you push to that. Now your code is up. So now I think we should try the breakout session. So what you do is you get your first experience with cloning if you haven't already done it. And you should clone this URL. There's a link also on the schedule page, I think, for the repository. You go into it and you look at the instructions, and there'll be some Git exercises. A lot today, but it's slowly getting replaced by distributed source control. So actually, Linus Torvalds has a good quote on CBS. He basically said, we're going to develop something, and CBS is the baseline for how we shouldn't do things. And if we're in doubt about anything, we should basically do the opposite of what CBS does. So that's nice. So decentralized. Basically everyone has a copy that is equal of the repository. It can be in different states, but it's just as good as the other ones. You can commit to your local repository and work on that offline. But when you're online, you can then push to some remote repository that's shared between people, or you can pull from it to get the other people's updates. Usually it introduces something called branches, which is a very nice way to experiment with new code, just doing something crazy that you don't have to release to everybody else, but you can still work on the what's called the master branch, which is what everybody else has. So there are different implementations of this. Can this go away? Okay, anyway. So there are different implementations of this. You can look those up. Obviously, Git is the one we're going to focus on here. And at last, I'm just going to mention some quick things about how to do packaging in Python. But in general, this is not about Python. This is about any kind of source code. Actually, any kind of files that you might want to have a history on. So, for example, for thesis work or papers, this is also a very good thing to do. So, version control. First of all, you want to have some kind of history of the development that you've been doing. Not only because it's nice to see what's the evolution of the code, but you also want to be able to go back and forth. Maybe you introduced an error, you want to not deploy that to some system that will break for everybody. The second good reason is to be able to do collaboration. So a lot of you obviously do a lot of collaboration with other people, and if you don't want to package all your software, send it to someone else, and you manually have to afterwards merge things together that you both worked on, version control offers a solution to that. It also, and I'll get a lot more into that, it makes it possible to do experimentation on your code or on your text or whatever you have without actually breaking stuff. You don't have to worry about that something breaks or you can never get back to the state that you had if you've created a commit, and we'll get back to what that is. So I'm just going to introduce some basics Git. It's a very complicated system. I don't fully understand everything of it, and if you don't, it's okay. It's Linus made it, so it's okay if you don't understand it. But basically, if you Google for any of these, you get very good references to help. So the Git tutorial is a nice just introduction to how to do basic stuff. The Git book has everything if you want to dig deeper. So let's get started. What you basically do is go to your directory and you call git init. You're now setting up Git so that it starts to work with your files. So by now it's an empty repository. The directory is empty, but we haven't added anything to it. So you can call git status command, which is something you use a lot. You get an overview of what's going on in your repository. So you can see we're on the master branch, which is a special name branch. We are currently working on an initial commit. It's a special state where it's just been initialized, but we haven't added anything to commit yet. So it tells us what to do. We should add something.
So by the way, for those that don't yet have Git, if you go back to the installation page of the website for the class, you should see some pointers to various flavors of Git. And it should just be a drop-in installation.
Okay, so I'm going to talk a bit about version control and specifically Git. Git is created by Linus Torvalds, the guy who also created the Linux kernel. He's a bit special. He cares about his software, and that's also why this is taken off. But this is a quote from the Git mailing list where someone's been very nice and implemented very nice color encoding of the output from Git commands, and he thought it looked like digging out your eyes with a fork. So they had to change it. So he's a good example of one of the benevolent dictators for life, like the Python founder. He controls Linux and Git very well. So one thing that's very important is that you should definitely use version control when you write software, especially if it gets larger. Linus thinks so. It's going to be, you have to spend some time to actually learn to use it, but once you do that, you'll find that it's pretty much required. Just a quick outline. I'm going to go through just a quick introduction of version control software in itself, then some more details about Git. You can basically always recover your state. So as I said before, it might take a little time to learn, but it's worth it. So just a quick terminology slide. What you usually have in any version control is the notion of repositories. In most version controls, it's basically just a directory. You check out the repository into a working directory. We'll get back to that a lot later. You do commits in order to change your code or whatever you have. You then update remote repositories or the shared repository with your changes. And then there's the notion of a centralized version control system versus a decentralized or distributed. So let's look at the centralized. So in this paradigm, everyone basically commits to a central server, there's a lot of problem with that. As you can probably imagine, you have a single point of failure, that server goes down, nobody can access or commit any code. If you're not online, if you don't have that server available, you cannot commit. And there's a couple of historical implementations of this. One is CVS, and that's basically what people used in the early days of computing. The other well-known of these is Subversion, and actually also used